Hello, this is the final presentation for the project Flight Simulation. Our team is conformed by Eduardo Torres, Ulises Salgado, and Tania Tapia. The goal of our project consists on simulate the flight of an airplane in a mountain environment, where the user will be able to control the plane direction with the keyboard, so the rotations and the translation of itself.
What is a terrain? In game applications, a terrain is one of the most critical components in the scene and can be easily the largest object in a project. There are two types of terrain representation, top-down and perspective. Top-down is used in applications such as cartographic maps, while perspective is used a lot in video games. We will be using perspective since we need to be able to see the terrain from different points of view depending on the airplane's position. What is a height map? In computer graphics, a height map is a raster image used to store values, such as surface elevation data, for display in computer graphics. A height map contains one channel interpreted as a distance of displacement of height from the floor of a surface. Black color represents minimum height and white representing maximum height. A height map is represented by a 2D array of values, where for any point x, y, and z, the x and z are the indexes into the array, and the value of the array is the y value, which is equivalent of the height value. This is an example of our height map that we use in our terrain.
To create the airplane, we use hierarchical models. But what hierarchical models means? In computer graphics, they describe the relationships between objects. They can be represented on two different ways, with trees or direct acyclic graphs, where the edge contains the transformations and the nodes contains the geometry and the drawing attributes. These kind of models can be very useful if we want to reuse code and connect primitives to get build objects. For the project, we're using trees because it's an easier way to conceptualize the structure of the plane. This is the basic implementation of a plane. We can see that the cockpits, the wings, and the landing gears are sub-objects of the body of the plane, but at the same time they are parents of their sub-object respectively. Before we talk about environment mapping, let us first think what we will mean by the environment. So far, the examples have mostly been with a black background, as if the objects were allocated in an empty space. This is usually not the case, and we want our scene to be located in either a closed environment, example in a room, or in an open environment, like an outside with a visible sky. To create this type of illusion, it will be necessary to use a skybox, that in computer graphic means that is a large texture box around the world for displaying very distant objects that cannot be reached.
Now we will explain our code to generate our terrain. We have three key functions, but after all, we will see this structure is very important. It has six variables that we will be using a lot in this code. The first function is leer archivo. In this function, we will read the txt file. It means we will read the height map and the values that we will consider in the following functions. Then we use find normal where we calculate the course product of two vectors, vector 1 and vector 2, and this function returns the normal without normalize. Then we use encontrar north there. Is used to find the normal of the terrain using find normal, the function that we already explained. And in this function we normalize the normals of the terrain. Finally, we use dibujar terreno. Uh, we use HL triangles, HL normal 3F and HL vertex 3F with the help of the first structure, vertex, that we mentioned. And for the normal 3F, we use the variables nx, ny, and nc. And for the vertex, we use x, y, and z.
To create the airplane, we will be using the structure provided in class 3node, which contains two methods to transform and draw each of the nodes. It also contains two structured tree nodes for the siblings and the child nodes. We will be using cuerpo, cabina, pico, ala, fugas, llantas, y ruedas as variables to create the nodes of the airplane. We can see here that we have created each of the methods to render each node. Also to transfer each of them, depending on where part we want to collocate them. Now, on the method creating sect, we have the main structure of the airplane. We can see how we are connecting each of the nodes to finally get a model of the airplane. We also have created a method to apply the material to the airplane. In this case, we're using Ruby material. Finally, on the display method, we apply certain translation, this one because of the terrain, so the other, and finally, we traverse the body. To create the skybox, we will be using different variables. We will be using inf, that is a f stream. This is to call the texture. Tamaño skybox to apply the size of the skybox, and the and name for the number of textures. In this case, only one. Now, on this method called a skybox, we have the different functions that needed to be called in order to create the skybox. We have mapped each of the sides of the skybox to create the appearance of a cube. We have the left side, the front side, the right side, the back side, and the roof of the skybox. On the display methods, we map only the skybox, applying some transformation in order to place according to the terrain and the airplane's positions. And finally, on the main method, we apply the texture, calling the texture when it's stored. And finally, set it, apply it to the my texture variable. Now we can finally show the final implementation of our code. We can see that we have the mountain and the terrains created with the high maps. We also will start viewing the back of the airplane created with primitives such as quads, cubes, and spheres and cylinders. The user will be able to move itself with the keyboard keys such as T, G, Y, H, U, J, I, K, O, and L. We will be using these keys to move from the side. We can go up, we can go down, we can go to both sides and simulating the natural movement of the airplane. We have used some limits from the skybox. So if the user go farther than that, it will cross the skybox and it will not let him go any further. This is the final implementation. Thank you very much.